This is the 12 volt version of the RPS Tesla switch, relative potential switch. There are four 12 volt 7 amp hour batteries. 12.98 should be the exact same. They're wired in parallel. And then we have series connection here. 24.94 for the series stack. 24.94 and about 12.98 there. So the relative potential then between the negative poles is 11.96 volts. It's because this is a relatively high voltage, almost 13 volts already. And that's at 24.95, almost 25 volts. So 25 minus 13, a little over, a little under rather. And that's the difference, 11.96 volts. And if you have an inverter, you put the inverter on there, making sure you make the negative of the parallel stack the positive to the inverter, and the negative of the series stack goes to the negative of the inverter, and that'll give you your 12 volt potential. You'll want to watch the voltage on the parallel stack, because the parallel stack will increase in voltage directly in proportion to the amount of load drawn. So if it's a high current draw, these batteries will charge up very quickly and you could burst them easy. These are gel cells. If it's lead acid, you have a bit more of a concern. Gel cells will boil and then they'll become worthless. They'll burn up whatever liquid is in the gel. And these are only rated for 7 amp hour, which is roughly, at the C20 rate, it's about 300 milliamps for 20 hours, which is what C20 means. So, yep, that's the 12 volt relative potential switch. So the next thing to do then is to directly load it. When it loads, the series stack will discharge, parallel stack will charge. Then you can flip it around. You can run the inverter with the light. While it's running the light, it's charging this stack. And then you power it off, flip the battery stacks around, put it back on the inverter to run the light again for another period. If you have a solar cell, there's a way to hybrid this and cascade it depending on the voltage that you're pulling off the cells. So, anyway, there you go.